All right, so I'm Daniel. Like Ben said, I'm also a research scientist at University of Virginia. That's really new. I'm a PhD student at Virginia Tech. I am a instructor for data camp, so if that's also where you've probably seen me around. I got all my teaching experience from software carpentry, which has become the carpentry. So if you also want like materials to free online resources, or if you are thinking about running a workshop, that's probably a good place to look for just pre-made material to look from. And I also am an author for this book. It's about Python, but it's in our meetup, or it's in our conference, but that's okay. We'll just go right into the base of this talk, which is about functions. So this is what a function looks like. You have a variable, essentially, like my function. You give it the arrow. The word function is how you create functions, and then you have a bunch of parameters, and then the function body. So if David Robinson ever gets to see this talk, he's going to hate me because he hates these types of functions that are like doing nothing. So I'm going to write a function that just adds 1 to something, or just adds something. So this is what writing a function looks like. And calling a function, you just call it by the variable that you got it, give it a value. As you can see, usually I have like a computer in front of me so I can like point to things. So in the my function function that I wrote, I have y equals to 1, so that's like setting a default value. So I can just pass in just one value, in which case I'll get 11. Or if I specify both x and y, it'll treat it accordingly. So our functions are just like other objects. So just like I showed you, you can say my add 10 and 20 will give you 30. But you can also like treat a function as like a regular object and reassign it to another variable. So now I can say another add is also 10 and 20. It's really just the same thing, right? And that's really just to show you that, like, yes, as you're writing functions, functions themselves can be arguments to other functions. And then when you're writing functions, there's this also thing called anonymous function. So that's really a function that you don't really assign back to a variable. So, we can say like function, we can essentially rewrite my add and say function x comma y equals 1, and then the actual code. And then you can actually call anonymous functions. So here you'll see the second set of round brackets, which is actually like the function call. So about scoping. Things that happen in a function really stay in a function. So if I have this function that takes in one parameter and I have inside this function I say y gets 1 and return x plus y, that makes sense. If I pass add 1 a value, it'll give us 2. If I pass it another value, it'll give us everything accordingly. But if I outside of the function definition define y, so for example y gets 10, and I also call this function what is it, add 1 gets 100, I still get 101, right? Because it's not using the y that I set in the global environment before the function call, it's still using that y is 1 within the function, right? So this is really important when especially if you end up reusing the same variable over and over again, that the scoping thing is probably something that will trip you up sometimes. So, if you're really new to all of this, just pick a different variable name, and then so you don't get really confused. But just so you know, when you run a function, it essentially creates its own environment, and that's the first place R will start looking for variables. So, for example, if we just have this other function that does nothing, but it just adds 2 values together, I can say, hey, when I call this function, it's going to get the x and y that I defined within the function and return 30. If it can't find something within the function, then it will go one step out and look at the enclosing environment, right? So in this example, I have a function that I'm calling within the global environment. So when I say return x plus y, it's going to get the value of y, which within the function I have set to 200. But because the function itself doesn't see x, it'll go up into the enclosing environment, and it finds x, which is 100, and then you get the value 300. So if it doesn't find that in the enclosing environment, it'll just keep going up and up. So if you can imagine like having a function within a for loop that you're calling in the global environment, it'll just keep going up. But if it can't find it, you'll actually get an error, right? So that's what this last line is showing you. So when do you write functions? So like, how many of you guys are like pretty new to R, right? So the general rule of thumb, if you ask a lot of people around, is like if you end up like hitting Control C or Apple C, pay attention to how many times and you end up hitting Control V or Apple V. Generally, if you see yourself doing that more than 3 times, it's time to write a function, right? So I just showed you how you can write a function. And so this is an example that I literally did yesterday because this is like a less, this is actually something I had to do. So here are some websites that point to open source projects that are run by the federal government in some agency. And there's this package called URL tools that you can actually get the domain out, because I was trying to find out like which of these packages are stored on GitHub or not. And so you can see like I wrote the same bit of code 3 times, right? And the only difference is like that actual innermost call to domain, which is like repos get the first one, the second one, or the third one, all right? And so you can imagine this being a more complicated thing. Let's say I did this 10 times across an entire script. And I realized that like, hey, I don't want domain, I wanted some other part. Now I have to remember to call, to change every single one of those locations, right? Or when you're copying and pasting, you're gonna forget or to change like one of the parameters, right? Like this is only one value that I'm changing, so I can actually count in my head like, did I change this thing 3 times or not? But you can imagine like if I'm copying and pasting and there's like 4 different places to look in, it's really common to like forget to replace a value. So we can turn that thing into a function. It's a really simple function, but let's write this function called getDomain. It takes a function, and then I can reuse that 3 times. But we still have repetitive code, right? So I still have to call that thing 3 times. So how do you get rid of repetitive code? One way is to write a function, and if it's still repeating, if you're calling a function multiple times, then you write something like a loop. So you could do something like a for loop in R. Here I'm using seek along to go iterate through each value in repos and printing the value of get domain. Or if you want, you can create a vector, get that result, and then insert it into the new vector that you want. Seek along is a bit more robust than just doing something like 1: length of something, mainly because if, for example, you pass in an empty vector or something that's 1 to 0, for example, seek along will just give you 1, and it won't actually like error out on you. So if you're thinking about like writing a little bit more robust code, you'll probably end up using seek along versus 1: length. So how do we write? You'll also hear about like for loops are bad. For loops have their place. Sometimes I'll write a for loop, and if I get the code working, I'll rewrite it just so it looks a little cleaner. So you might have heard of the apply family of functions to iterate through multiple function calls. So I can do the same thing in that for loop, but call sapply. And I can say like, here are all the values, and then for each one of those values, plug it into my getDomain function. And you can see we get the same results back. But the tidyverse has this library called pur, or pure R. And there's this function called map. And map runs just like the apply family of functions. You give it a .x, which is like those repos values that we want, and .f, which is the function that you want. So you can see here that when we call map repos and get domain, we get those domain values back. What's cool about pur is you get to specify the output type, right? So you're not stuck with getting a list back. If you really want a character vector back, you can say map_car. And you'll get the same thing, but as a character vector back. And there's a whole bunch of these. Like if you wanted a data frame back, so a really common thing is you get everything to a list of data frames, and then like you bind the whole list together, right? But in pur, you can just say map df, and it'll just give you the data frame back, right, with everything concatenated together. You can also have anonymous functions in pur. So here, the .x, that's the repos, and then the .f, instead of passing in the function that we wrote, we could just write our function as an anonymous function. So here I'm just really running string to lower just to make sure that the URLs are all in lowercase before I call getDomain. This notation of like function x getDomain string lower bracket x, that's such a common idiom that you can rewrite the exact same thing with the formula notation. So the thing on the bottom is really exactly the same thing as the one above. So if you start seeing tildes like in the middle of like a dplyr pipeline, that's really what it's doing when it's calling pur. So pur also has this thing called map2, because some functions don't just take 1 value, they take 2 values. So let's have this function x comma y. It just adds those 2 numbers together, but we have these 2 vectors, v1 and v2, and we want to in the same location, add those two values together. So in base R, there's this function called mapply. So you can say like, hey, this is my function, and these are the parameters that go into mapply. But in Perl, you have this map2 function, and then the end result that I'm looking for is a double. If you want an integer, all of those values have to have a capital L. So like one capital L is how you specify an actual integer in R, but these are all double values. And you can see we get the same result back. We get a vector of numeric values. So you can also like keep extending on this, right? So you can have like 3 or 4 or 5, but instead of like creating like a map3, map4 function in Perl, there's just pmap. And so you can see here I have like 4 values. This function takes 4 values, or I have 4 vectors. This function takes 4 values. And then we can say pmap double. So like the code is really consistent in all of tidyverse. And the only difference here is you have to pass in a list. So x, y, z, a gets those vectors v1, v2, v3, v4. And then we pass in the function that we want to call. So something else about pmap, what if you want to put in values that's not the first argument into the function? So that's really similar to the anonymous function or in the map call that I showed you earlier, right? So this is something that I've had to deal with, was like, hey, like these data, these dplyr pipelines like just pipe everything into the first argument, but I want it like in the second because that's how the function was actually written. So you can do the same thing of writing an anonymous function. In this case, I'm using the shorthand formula notation. If you kind of go back, it's really doing the same thing. So within Perl, it's also really cool because sometimes you have like a vector of values, and you just want it to like run, and just, you know, it's really annoying when like there's 1,000 values and it just errors out on like 999. And you're just like, why couldn't you just finish the last one? So in Perl, this is really cool because there's this function called safely, which if there is an error, it'll just capture the error for you and just keep going, right? So at least you get a result back. So you can see here, I have this list. So I'm not using vectors anymore because vectors all have to have the same type in R. So we have a list, 1, oops, and 5. And if we take the log, you'll see that like oops can't be logged, right? But if we just take our log function, just wrap it around the per safely function, you see that we don't get an error. What we do get back is a list, and this list has, we have 3 items in our vector, so we get a 3-length list back. Each element in that list, or each index in that list, has two parts, a result and an error. So if it did pass, you'll get something in result, and if you did have an error, you'll get something in error. Right? So you can see that we got 3 values back, everything came back. The second index, or the second value, there's something in error. And if you want, you can subset things out if you want to. So if I want the result portion of the first thing, I can say $result. If I want the error portion of the first thing, I can say $error. But that's really annoying too. So in Perl, there's this thing called transpose. So what you can do is if you say transpose of the results, if you just wanted a vector of all the results after you transpose it, I can just get everything by just calling result. So what does that look like? I can say per transpose results $result, and I'll get a vector of all the results. Or if I want to see what the errors are, I can just get a vector of all the errors, right? All right, so what else can you do with functions? So R is this weird language where there's, quoting from Hadley, there's this tension between like working in interactive mode and then people who actually try to build software. So non-standard evaluation is something that exists in R, so you can actually capture the code that the user is writing, not the value that the user put in, right? So you can see if you work in the tidyverse things, like, hey, how come like it just knows what this column is without quotes? For me, when I first saw this, it's kind of terrifying because it's not quoted, so it should be a variable, right? So that's what non-standard evaluation is doing. You see this a lot, not just in dplyr. So like when you do something in ggplot, here's a plot of using cars, not even empty cars. How does this plot know what to put in as the x label, right? Like it took the value that the user put in, right? So even if I do something like log speed, it wraps it around on the x and y axis too, right? So it's actually capturing what the user put in, but it's like not quoted as a string. It's kind of weird. So how does R do this? So there's this built-in method called substitute. So if you look at, if you substitute a value for x, and so here's a function that does nothing, but if I call like f of 1 to 10, I actually get 1 to 10 back. It doesn't return like the vector 1 to 10, right? It just gives you back exactly what you put it. So even if I give x a value 1 and I say like, hey, run the function on x, it'll just give you back x, right? So that's essentially how non-standard evaluation is doing, is capturing what you gave it, pretty much exactly how you gave it. If you dig around a lot of the R functions, you also see another function being used called dparse, and that just takes the thing that from substitute, but just gives it back as a string, right? So under the hood, you're not really using attach, because if you've heard about people like never run the function attach, this is what's really going on under the hood. So dparse runs a string, returns a string value back. So if you kind of squint your eyes, this is really just giving exactly what you gave it, because we're calling y, not any actual value. So one place that you see this a lot, this non-standard evaluation, is like the subset function. So we can say like, hey, here's our sample data frame, and I want all the values a that's greater than 4. And this just so happens to work without quoted strings. But we can also write our own subset function, right? So if you actually look at the source code, you'll see substitute and dparse in the source code of subset. But this is generally what's going on. Like we have a data frame and a condition. We're getting the substitute of the condition, so it's getting back the exact same value that the user put in. And I'm just printing these values just so you see it. And then once you get the string version back, you can use the eval function in R to actually evaluate something that you gave it. And in this case, the trick is we give it the string and then the environment x, which is going to be our data frame. And then the last line in this function just subsets our data frame just like normal. So why is this a good thing? You get to separate the code that the user is writing from the backend. So like dplyr does this. That's why you also have something called dbplyrs to work with databases, or dtplyr to work with data table. And it doesn't matter what the input is, your pipeline will work. The scary thing is this NSE makes functions, I cannot pronounce this word, referentially transparent, meaning that if you put in different values that are really the same like equivalent object, you get a different result, right? So if I put in x and y, I'll just get x and y, even though they could theoretically be assigned to the same value. So last 2 minutes. How does this all work? There's this thing called tidy evaluation. You'll see this when you're working with a whole bunch of dplyr or tidyverse stuff. This all comes from Rlang, so the Rlang library, and there's this actual quote-unquote book-down book about tidy eval, which I also just stole this presentation from. So in base R, there's this quote function. And the equivalent to quote in base R is this expr function in Rlang. And then for substitute, it's an expr. So essentially what you give it is what it will spit out. So in Rlang, the thing that you'll see the most, or how does this all interact with how you want to build functions in tidyverse, is this bang bang operator, or 2 exclamation marks. And what that is doing is unquoting the string. So you can see that if I run expr of a plus b and I assign it to x, I get a plus b back, right? But if I say bang bang x in the second line, I don't really get just x, right? It tries to evaluate it. It unquotes that string. So when I say bang bang x plus c, I get a plus b plus c. So how does this work in tidyverse? So we have this. Now I'm using empty cars because I needed more columns. So we have one plot, another plot, and then another plot. And so I've just made like 3 plots doing the same thing. So let's make this a function. So if you don't get anything out of this, just put bang bang in front of your functions, in front of your variables to unquote strings. So here's this scatter plot, takes the data frame x and y, and we have to use n expr to take the value that the user gave it and then unquote the string. Yeah, that's 20 minutes. Stop. Stop. I'm almost done, right? Yes. Okay. So we can now take our myScatterplot, and you can now see that I can pass in unquoted strings, and it'll give us our plot back. So what about the environment? You know, here the function itself calls n. If you look at the last line, when I say df x plus n, it's really using the n inside the function. There's this thing called a closure, which is a closure plus quotation that also captures the environment. So that's why when you're running dplyr pipelines, you can also reference variables outside of the pipeline itself. And so that internally it's using this nexpr because it's trying to capture the environment. If you squint your eyes, and also my slides are posted, so you can look at this later on. But you know, if you don't get anything out of this talk, just use bang bang, and in a combination of nquo to quote and unquote your strings. And so if you need anything, here's a picture for all the slides. Everything's posted, and I think I'll just end up sending it to the conference organizers at the end as well. So thank you.